All right, folks. Another function from problem set number 2, question number 4. Another unassigned function that we will find the derivative of together. Okay, so this one now, j of x, kind of an interesting function. This is going to be a fun one to take what's called the second derivative, third derivative. So when we're done, I might just go a little bit further just to see what's going on. But all we're asked to do in the instructions is find the derivative. So first, looking at this, I've got a subtraction right there. Right, so a difference. So taking the derivative as far as the two terms being subtracted, that's no big deal, right? We have our difference rule, which just says take each derivative separately and subtract those. But here we do have a product. We have x times e to the x. All right. So to figure out the derivative of that thing, let me do the product rule a little bit differently than or demonstrate it a little differently than I did in the previous example when I did the function g of x. So here, let's say, just on the side, I'm going to say let f of x equal x, and let g of x equal e to the x. Okay, so those let statements are just a nice way of letting the reader know that you're introducing your own notation, or you're introducing your own name for this function. Okay, and then once we've introduced it, then we can take the derivatives, though. So then f prime of x is just going to be 1. And here I've got g prime is the derivative of e to the x, which is itself. Okay. And so those 4 pieces are sort of my building blocks for the product rule over here. And then I've got just the subtract the derivative of this e to the x, which is just going to be itself. All right. So let's get going. So I've got my pieces set up, and so now we can say j prime of x and start with our derivative. So here, since I introduced this notation, let me just take a second and maybe show the product rule sort of happening here. Okay, and so remember the product rule, we have a little bit of leniency the way we want to combine our terms or the order that we want to combine them. So let me do this one. I'm going to kind of mimic the way I wrote my quotient rule, the numerator, which is not always the way I use my product rule. I kind of do it differently sometimes. But the way I did that was g times f prime plus f times g prime, right? We know the quotient rule needs to have this order, and then we would have a minus sign and g squared and such. But there we go. So we've got those pieces, and then we're going to subtract from there the derivative, since we didn't address that guy yet, the derivative of my e to the x. All right. So again, similar to the previous video, I'm kind of setting the stage here, telling the reader sort of what I'm going to do, which derivatives I'm placing where, which regular functions I'm placing where, and then what I'm going to do from there is fill everything in and then clean everything up. So my g is e to the x times the f prime is just a 1. So do you have to show that? No. Is it nice to show? Yeah, right, because it tells the story. So as I'm reading from one line to one line to one line, almost imagine what you're writing is for someone else, that you're a tutor or a teacher, and you're going to show that to a student of your own and say, here, can you follow this, right? So they might say, hey, where'd the f prime go? So it's not terrible to show it in its place, and then later, times 1, we might take away. Over here, I've got plus my original f, which is just an x, times my g prime is an e to the x. All right, and then I'm subtracting the derivative of e to the x, which is a copy of e to the x. All right, so there we go. And so what do I have left here is I've got e to the x times 1, right, which is just an e to the x. So e to the x, and then over here minus e to the x. So those things are actually going away. And then the only thing that is left behind is this x e to the x. All right. So there we go. We started with this j function right there. And we took its derivative, and we got, notice what we ended up with is x e to the x, which was a piece of the j function, right? The original j was that, and then we were subtracting an e to the x. When we took the derivative and we did our product rule right here, right? The product rule reproduced the original piece right there. This derivative reproduced that original piece, but then the product rule sort of also spit out this little term right there that ended up canceling this e to the x. All right. So this is a fun one because I want to keep going a little bit just to see what happens as we push this idea further. Take the second derivative of j, meaning the derivative of j prime. Right, so let's do it again. So let me erase all this stuff. Had I assigned this problem for homework, we'd be done right now, right? So everything I'm going to do now is just a little bit extra. J of x was this, or j is right there, and we just found that j prime of x was just x e to the x. Okay, so this minus e to the x from the original j sort of went away. Let's go further. Let's take the derivative of j, which is going to be j double prime of x. So we call this the second derivative of j. Sort of count up those primes right there. And so I'm just going to kind of rush through the product rule a little bit more quick this time. We've actually already done the product rule, right? Everything we wrote earlier here was the product rule for this function. So we had the first function, x, times the derivative of the second function, which produces another e to the x, though. I think I'm doing this in a little bit different order, but it's actually going to work out nicer. The first function, x, times the derivative of e to the x, which is e to the x, plus, let's say the derivative of the first function, 1 times another e to the x, right? Times the original second function, which is still e to the x. Okay, so notice what happened this time. Here we had x e to the x minus an e to the x. When we took the derivative of that function, the minus e to the x went away, right? So we kind of added an e to the x in a way, right? It combined with that and went away. And now, if what's happening here is I've got x e to the x, which I could rewrite as this, x e to the x plus e to the x. Right? 1 times e to the x. So it's cool, it kind of came back, but now it's positive. Okay, so let me write down j double prime, and then I want to go further. So if I go j double prime, we just got this original x e to the x, and now we have a plus e to the x. All right, let's take the derivative of that. Go a little bit further. So let's say j triple prime of x. The third derivative of j is, we've already taken the product rule of this. We've done this a few times already. We're going to get the first times the derivative of the second plus the second e to the x times the derivative of the first, which is a 1, which just produces a 1 e to the x coming out of that, or another copy of e to the x. And then now plus, right, so now using the sum rule, so all of this stuff right here is the derivative of that product, plus the derivative of this e to the x, which is e to the x, right? Another copy of itself. And so what did we end up with here? Again, we keep reproducing this thing, x e to the x, plus, now I've got a copy of e to the x, plus a second copy of e to the x, I've got plus 2 e to the x. All right, so maybe if you're keeping track of what's happening with all these subsequent derivatives, you're seeing what's happening to the answer right there. So j triple prime is x e to the x plus 2 copies of e to the x. All right, let me just sort of argue out loud what's going to happen to the fourth derivative. So the fourth derivative, first of all, at that point, usually we switch our notation for sort of deeper and deeper derivatives. In other words, I could draw 4 apostrophes, and you could argue that's reasonable still. But what if I wanted to take like the 12th derivative or the 24th derivative of some function? That could get a little extreme, right? Drawing all those parentheses. So typically what happens, the convention is once you hit the 4th derivative, you put what looks sort of like an exponent for 4, but then we wrap it in a little set of parentheses right there. So we know it's not an exponent. That indicates that we're taking the 4th derivative, which really is just the derivative of the 3rd derivative, right? So we just keep going deeper and deeper. And let's try to see what was going to happen to this thing. Every time we take the derivative of x e to the x, we end up with x e to the x plus that additional copy of e to the x, right? So this guy produces this. Now here, we've got e to the x, we've got whose derivative is itself, and then we've got a constant multiple of 2, and the constant multiple comes through the derivative process. So this term produces 2e to the x, and then what happens? Then we can collect our e to the x terms, and now I've got 2 of them plus an extra 1, so I've got 3 e to the x. All right, so there we go. So x e to the x plus 3 e to the x. Okay. Here comes what I call pattern recognition time. What if I wanted to find the 23rd derivative of j? Right? 23rd derivative of j. Just had a fun idea. Extra credit, email me what number belongs in that box. Let's say before Sunday, so sometime Saturday night or something like that. If you've watched this video, let's say before Sunday night. But before it turns stroke of midnight, so before Monday kicks in. And yeah, just tell me what belongs in this box. Just for a fun exercise, I just thought of that. Now, see who watches these videos. See who watched the whole extra portion of me doing all this extra stuff. But there you go. Another way to write some of these also is, since this has an e to the x, you could be factoring that out. So here I could write x plus 3 times e to the x, right? Factor the e to the x out to the right. In that case, I've got here is x plus 2 e to the x. Here we had x plus 1 e to the x. And let's backtrack this pattern all the way to the original function here. This I could call x plus 0 times e to the x, right? That's not incorrect because x plus 0 is just x, right? That's the multiplier there. And then now this becomes either x plus -1, or we could say x minus 1 e to the x, right? So it kind of keeps working backwards. We ran out of positive numbers, hit 0, and then we start -1. So what would happen if we went backwards even further? Is that possible? Can you go the opposite direction of a derivative? So some things to think about. Anyway, for funsies, for an extra whatever, I don't know, something I'll add. But yeah, send me that.